Okay, oftentimes we have a situation where we have two masses, let's say A and B, connected by a string or a rope, and we assume that the rope is massless, and I want to show you what the consequence of that is. So let's say that we have a system here consisting of a rope. So let's initially assume it has some mass m sub s. Attaching A and B together, and there's a force, a rightward force acting on B, causing this system A plus rope plus B to accelerate to the right. So we could do a free body diagram for A and for B and for C as shown here. Ignoring any vertical forces and ignoring any friction, the force acting on A would be the tension force of the string on A, and the force acting on B, the forces acting on B, would be the tension force of S on B to the left, and then the force F acting on B to the right. And in the middle, then we would have a reaction force on the right side of the string of T of B on the string, T of B on S, and we'd have a reaction force on the left side of the string, T of A on S. The dotted lines again show the reaction pairs. And then if the system, if the A and B were accelerating to the right with A sub x, well, that would mean the string would also be doing that. And in that case, the net force on the string would be T of B on S minus T of A on S is equal to ms A sub x. That would be a Newton number 2 for the string. So if we set ms equal to 0, which is the massless string approximation, or make it very, very small, in either case, practically speaking, we can set, as the title to this chart says, T of B on S is equal to T of A on S. That's a consequence of setting the right side of this equation equal to 0. And if that was true, then if T of A on S and T of B on S are 0, well, that means that essentially we can set T of S on A equal to T of S on B. In other words, we can ignore the string entirely, and from a practical engineering standpoint, pretend like A and B are directly connected, and simply say T of B on A and T of A on B. And your book refers to this as if, because it is in fact a shortcut for this more complicated picture up here, and we will usually use this shortcut, so it's good to know where it comes from.